In this video, we're going to solve systems of linear equations by substitution. Our first step in the process is going to isolate one of the variables. Isolate just means to get one of the variables by itself on one side of the equal sign. Step 2, we will substitute that into the other equation. Step 3, solve for the variable. Step 4, after we solve for the variable, we will then take that answer and substitute it into any of the original two equations. And once we substitute into the original equation, we will solve and write our answer as a coordinate. So we will follow these steps as we work through these examples. So for example 1, our first equation is y equals -2. Second equation is 4x minus 3y equals 18. Now looking at our first equation, I see that it is y equals -2. So for this example, we already have an equation that has isolated one of the variables. So step 1 was already done for us. Now, step 2 says to substitute into the other equation. Okay, well, if y is equal to -2, that means whenever I see y in the other equation, I can then plug in -2, like this. So 4x minus 3, but instead of putting y, I'm going to open up parentheses and put -2 because we know y is equal to -2. And then finish it off, equals 18. Now, in this step, it says the resulting equation should have only one variable. So you should check to make sure that there is only one variable in our equation, which there is. So we're good to go. We can go ahead and finish evaluating and solving for x. So in the next step, we just need to multiply -3 times 2, -2, I'm sorry. So it'll be 4x plus 6 equals 18. We still need to solve for x, so -6 minus 6, 12. And then in our last step, we need to divide by 4. So our x value is equal to 3. Now, that's only half of our answer because we're supposed to represent our answer as a coordinate, x comma y. So we know the x value is 3. Now we just need to find our y value and we will be finished. So then that takes us to step 4. Substitute the result, our result was x equals 3, into any of the original equations. You could pick either one. For this example, the first equation does not have an x, so we're not able to plug into the first equation. So we will plug 3 into the second equation. Okay, so 4, but instead of x, I'm going to open up parentheses and substitute in 3 minus 3y. And it's okay that the y is still there because at this point, that's what we're solving for. Okay, and then just like before, we just go ahead and evaluate. 4 times 3 is 12 minus 3y equals 18. We need to subtract 12 from both sides. -3y is equal to 6. Last step, we need to divide by -3. So our y value is equal to -2. So now we have both parts of our answer. We just write it as a coordinate and we are done. Now for example 2, it's slightly different. We don't know exactly what one of our variables are, like we did in the first one. Like we knew y was equal to -2, so we can go ahead and start there. But if you notice in the second example, y is isolated. They do have y by itself, but there's still x that we have to find. So our first step is going to be plugging in this expression for y, because we know y is equal to -3x plus 5. So that means wherever I see a y in the other equation, I'm going to open up parentheses and I will plug in what y is equal to. So -3x plus 5 equals -3. And then from here, you go ahead and distribute, because in order to solve, we have to get x by itself, but we can't as long as there's an x in the parentheses. So distribute to get rid of the parentheses. So that'll be -4 times -3x and -4 times 5. Okay. Then we combine like terms. 5x plus 12x is equal to 17x. Okay, we're continuing to solve. So I need to add 20 to both sides. And then we divide. So our x value of this solution is equal to 1. All right, so to finish this off, we need to find the other half of our answer, which is our y value. You can then take this x equals 1 and plug in 1 for x in either one of these equations. I will choose to plug it into the first one. So y is equal to -3, but instead of putting x, we know that x is equal to a positive 1. We finish off the equation, plus 5. And then we evaluate. -3 times 1 is -3. And then -3 plus 5 is equal to 2. So our answer for example 2 is going to be 1, 2. For example 3, we're going to continue to follow our steps. The first step is to isolate one of the variables. Well, in this example, neither equation has already solved for a variable. So it's up to us to pick an equation and choose a variable to solve for. It does not matter which equation you choose, and it does not matter which variable you choose to solve for. It'll all come out to be the exact same thing in the end. I will choose to solve the second equation for x because the coefficient is a positive 1, which means all I have to do is move the -2y over and I'm good. I don't need to divide after that. So let's go ahead and solve for x. So if we have x minus 2y equals 11, if I want to solve for x or get x by itself, I need to add 2y to the other side. So we know x is equal to 11 plus 2y. Okay, great. So now that we know that x is equal to 11 plus 2y, we can then take this expression, the 11 plus 2y, and plug it into the first equation for x. So let's go ahead and do that. I'll start it right here. So negative 7. Instead of x, we're plugging in 11 plus 2y minus 2y is equal to negative 13. All right, and at this point, we're supposed to only have one variable in the equation. And if you look, we do. All you see are y's. We don't have any x's, which is great. So that means we can go ahead and distribute and solve for y. Combine like terms. And we divide. And then we know that y is equal to negative 4. Now we just need to use the fact that y is equal to negative 4 to solve for x. And you can plug that into either equation. I'm going to use the second one. So x minus 2, but instead of y, we know y is now equal to negative 4. And that's equal to 11. So after we subtract 8 from both sides, x will be equal to a positive 3. So our answer, or the solution to the system in example 3, is 3, negative 4.